Okay, so today video is about the making of a NOT gate from a NAND gate. NAND gate basically universal gate, and by using this universal gate, I can make a NOT gate. So what we will do, we will just by making these both of the input of the NAND gate, and we'll make it a single input for a NOT gate. Because we all know that in a NOT gate there is basically one input and an output. However, in other gates there are two inputs and one is the output. But in NOT gate there is one input and one output. So you can see that in case of the NAND gate, there is, for example, its input A is 0, so input B can be 1, and vice versa. For example, it can be 1, it can be 0, both of them can be 0, both of them can be 1, because there are two inputs. In case of the NOT gate, we will just make it both of the input, we will just make it like this. For example, we will join these inputs and it would become a single input A or either B input. For example, it will become single input A. So what will happen, for example, if we give it 0, so both of the input would be 0, and it going to invert, which is the property of the NOT gate, it will be 1. But for example, if it is 1, so both of them going to become 1, and the output would be 0, which is the property of a NOT gate. So basically by using this one gate, we will achieve this one gate. Okay, this is basically the symbol of a NOT gate. So by using this one and by this phenomena, we are going to make a NOT gate. This is the truth table of the NOT gate. I know you may be aware of this truth table of the NOT gate, but just for simplicity, I'm going to tell you that if in a NOT gate, when it is 0, so the output would be 1, and when the input is 1, so the output would be 0. So now we will make the practical verification. So how to make a NOT gate from a NAND gate, which is basically a universal gate. Okay, so for the verification of this one, these are things which are going to be required. This is the breadboard in which the IC of the NAND gate are going to be put it in this one. And this one is the voltage DC source. This one is the LED, and this one is the IC 7400 NAND gate IC. Basically, these are the words that are going to be used in this one. So starting this one, I'm just placing this one. I see there's a slice cut, and I have told you in the previous video also that we will place it. The slice cut should be above or at the top side. Okay, I'm placing it here. Now this one is a shorter one. This one basically, this one is the VCC, and all the gates at the top right sides of all the gates are basically VCC. So we will make it, for example, consider this one column is a VCC, is the positive one, because I'm going to attach the positive side of the positive wire of the battery with this one. So I'm going to consider this one as the positive side. Okay, now giving it a ground or connecting with the negative terminal. So this one, I'm considering this one is the negative one of the breadboard. Okay, now we have given this one. What we will do, we will just shorten it, okay, or make it both of the input going to become 1. So for that purpose, what we will do, this one is the in the NAND gate, you can you know that this one is input A, this one is input B, and this one is the output. So what we will do, just this one, making this both of the input 1, and this one. Now these input have become 1, which means that, for example, and this one, you see this. This one, I am going to place this one, for example, here now, and this is the output. Okay, and for that, for the verification whether, and this one is the LED, which is going to be required in this one. Okay, I'm placing this LED here. You see this one, you must know, I've told you, but again I'm telling you that this one is the longer one side and this one is the shorter one. The longer one of this LED represents the positive side, and the shorter one represents the negative side. Placing it here. Okay, connecting the output of this one gate with the positive side of the LED, which I have done, and giving it a ground or connecting it the LED, the negative side of the LED with the negative column. Okay, as I've considered this one as the negative column, so it's going to become the negative column. Okay, now what happened here? Okay, yeah, there it is. Basically, both of the input, the input A and input B had become 1, Now this one input, basically this input, when I give it a 1, which means that I've connected with the positive side of the breadboard, so both of the input would be 1. And when I connect it with the negative side, so both of the input would become 0. So basically which is the property of the NOT gate. In the NOT gate, I have told you that there is basically one input and one output. However, in the other gates there are basically two outputs, two inputs and one output. So I by just making these two inputs one, I did it, and now I will just by just placing it on the positive side, so the both of the input would be 1, and both of the input basically would be 1, and by placing it here in the negative side of the breadboard, so the both of the input would become 0. So basically the input, both of the input become 1. Okay, now you see here, this one here, as I've given it the number 1 property, which is the 1. So the LED would be off. You see the LED is 1 second. Okay, wires are little loose, so for that reason that just remove. Okay, what the 1 second. Okay, you see this one, and I will place it here so it will not be removed. Now you see the LED is off, which is the property of a NOT gate. And according to the property of a NOT gate, when the input is 1, which means when the input is being connected with the positive side of the breadboard, so the output would be 0 and the LED is off. Now you see, when I place it here, you see LED gets on. So which is the property of the NOT gate, and according to which when the input is 0, which means the input is being connected with the negative side of the breadboard, so the output would be 1, and this LED get on, which is verifying the condition of the truth table of the NOT gate, that when input is 0, so the output would be 1. So this was the whole phenomena. I'm just removing these wires and just like this. Okay, you see what basically happened there, removing the other wires too, so that must get clear to you. Just removing this one, removing this one too. Basically we are interested in the inputs that I've done. So you see this one wire is the output wire, and I'm going to remove this one, okay, also, and this one too. These are basically, you see, the two inputs of this gate. You see this one and this one are the two inputs of the NAND gate, input A and input B. We just by connecting these inputs with each other, and now this input become one. This is basically these two input became one input. You see both of these inputs, you see this one, both of these inputs are now input A and input B had become either input A or input B. So just by connecting these inputs with each other, so this become a one input, and by this we will take either from here or here, in this row or in this row, and connect it a wire and place it anywhere, which will give us by which we are gonna verify the NOT gate, whether it is a NOT gate or not. So this was all about the making of the NOT gate from the universal NAND gate. For others, in the other video, I'm gonna make AND gate, OR gate, and NOT gate. So for that reason, you must subscribe and like the video. So please, thank you.